Good day. The topic of our research is data mining informational system for complex technical system failure risk evaluation. Authors are Vladimir Vychuzhanin, Nickolay, Rudnichenko, Tetiana, Otradskya, and Igor, Petrov. Well, the main problem statement and relevance leads in such things that efficiency of functioning of complex technical systems largely depends on the reliability of their interconnected interacting elements, inter-elements connections. The problems arising in assessing the risk of complex technical system failures are associated with a variety of equipment with structural and functional features differing in physical principles and modes in operation, making it difficult to use universal methods, means of diagnosis, and technical state of systems. In this case, it's very important to use data mining methods to automate such processes. So, taking into account the described specifics of the complex technical systems, one should take into account the heterogeneity and large amount of diagnostical data obtained for various subsystems and elements. So this increases the relevance of automating the search and identifying hidden patterns in the failures and violations in operating modes of components of complex technical systems. And it becomes possible through the use of modern methods of technologies of data mining. The purpose and objectives of the work are: the main goal is to automate the search and identifying hidden patterns in data with complex technical system modeling and risk evaluation processes. And the work objectives are analysis of literature in the study area, designation and substantiation of the research problem, development and description of the method for diagnostics and prediction of complex technical systems risk failures in data mining system, DMISI, and development of fuzzy probabilistic model of risk assessment and decision tree classifier as a part of data mining model, and research of the modeling results. In this slide, we can see DMIS structure, pipeline, and scheme. Pipeline has next stages. Object information becomes to initial data collection model, which processes data and make collections for initial data processing model. And next step, diagnostics model using fuzzy modeling methodology and cognitive modeling methodologies can provide risks assessment, and this data is used for forecasting model to have a control action formation model data, which helps structured data about risk failures and categories and actions we need to do with the elements and inter-element connections, and it helps us within a decision-making model to provide some prioritized task or list of tasks or recommendations. And the scheme is shown on the right side of the slide, and we can see that external data sources provided in different formats and forms, and all it comes to the database. Database used fuzzy models, knowledge base, and cognitive models. And the knowledge base is the result of working on fuzzy models and cognitive models. It aggregates all the data in structured order and send knowledge data to analysis and evaluation model, and then to forecasting model and data output model. And next data comes to the decision maker. The whole method of diagnostics and prediction complex technical systems risk failures leads in such formulas that provides as 1 and 2, which help us to understand how we can evaluate the risk in our data mining system in diagnostics model. Next, our stage is experiment and results. We create a model with a complex technical system graph structure. It consists of 20 elements and 26 interconnections. It's transport system of engine, which data of it is given by the OREDA database. And we, as a result of our modeling processes, we rank the values of the structural risk of failures by elements, and we can see the most critical element is number 3, 5.2, based on these results, we built visualization of fuzzy probabilistic model of risk assessment based on this data. And as a part of our system, we use data mining module of our system based on decision trees model. And we built a lot of, about 10 different decision tree models, and provide here the main, as general, the most stabilized of all of it. And we show the main our features of data set. We can evaluate the weight of each feature, or the most important features. As we can see, the structural risk, functional risk, wear, and failure mean. Next, we built focused data of knowledge, our knowledge base, as a result of that decision maker person have on the screen as a log. We provide different scenarios, about 10 scenarios, and in each scenario, our data mining information system gives us the most priority action scenario. It means the category of our works we need to do with the element or subsystem or interconnection element, interconnections, to avoid risk of system failure. We can see no action, prevention, replacement, and repair. There are 4 different categories of action, most priority action scenarios. We can print to the decision maker as a result of our data mining informational system works. Conclusion: we would like possess that data mining system has been developed for diagnostics, predicting failure risk assessment of designed and operated interconnected and interacting elements of complex technical system. Based on the application of the method and cognitive imitation, fuzzy probabilistic models of failure risk assessment, and within a decision trees model. Knowledge base of the proposed system is based on the methodology of cognitive and fuzzy probabilistic modeling. Also, we use the decision tree model to store the metadata of whole our big data set that we built, about some 10 or 100 of gigabytes data, which makes it possible to take into account the scenarios of the development of the risk of failure of elements and inter-element connections of the different systems. The use of developed methods and models in the intellectual system and data mining system makes it possible to access the reliability of system based on the results as effects of the damaging effect of each element in emergency scenarios, such as we can see on the previous slide, on the structure of the system, as well as to predict the consequences of failure of elements and inter-element connections of systems. The practical application of the development system can be performed by automating the tasks of collecting and processing data from various complex technical systems, especially in the transport sector, as we can see on our graph model presented earlier. Thanks for attention. There are our contacts info. We are open to any working processes in our field. Thank you for attention. Topic of research is finished.